Yes, using a Class 1 Division 1 rated switch located next to the motor in the Class 1 Division 1 room to operate the coil of a contactor rated 50 amps located in a control panel to disconnect power to the motor is a permitted option instead of installing a 50 amp 3-phase Class 1 Division 1 disconnect in the room next to the motor. Here are relevant code sections. Firstly, 501.6 disconnection of equipment. Secondly, 430.102 disconnecting means for motors. Thirdly, 430.110 overcurrent protection. Section 430.110 requires overcurrent protection for motors. In this instance, the 50 amp fuses in the control panel provide overcurrent protection for the motor. Section 430.102 allows for a disconnecting means to be located outside of a Class 1 Division 1 area if the disconnecting means is arranged to be operated from outside the hazardous classified area. The Class 1 Division 1 rated switch located next to the motor in the Class 1 Division 1 area operates the coil of the contactor located in the control panel in the unclassified area. This arrangement satisfies the requirement of being able to disconnect the motor from outside the hazardous area. Therefore, the proposed arrangement is a permitted option. Let's delve into a more detailed discussion regarding motor installations in Class 1 Division 1 locations, focusing on the specifics of the disconnecting means and overcurrent protection. Understanding these requirements is crucial for ensuring safety and compliance with the National Electrical Code, or NEC. Class 1 Division 1 locations are defined as areas where ignitable concentrations of flammable gases, vapors, or liquids are present continuously, intermittently, or periodically under normal operating conditions. Due to the inherent risk of explosion in these environments, all electrical equipment must be specifically designed and approved for use in such hazardous locations. This often involves explosion-proof enclosures and intrinsically safe circuits to prevent ignition of the flammable substances. When installing a 3-phase motor in a Class 1 Division 1 area, several key considerations come into play. One of the primary concerns is the disconnecting means, which is the device used to isolate the motor from the electrical power supply. According to Section 430.102 of the NEC, a disconnecting means must be provided for each motor, and it must be readily accessible. In the context of a Class 1 Division 1 location, the disconnecting means must also be approved for use in such hazardous environments. This typically means using an explosion-proof disconnect switch that is specifically rated for Class 1 Division 1 applications. However, as the initial scenario illustrates, there are alternative approaches to providing a disconnecting means that comply with the code while potentially offering cost or convenience advantages. One such alternative is to locate the disconnecting means outside of the Class 1 Division 1 area and use a control circuit to remotely operate a contactor that disconnects power to the motor. This approach is permitted by Section 430.102, which allows for the disconnecting means to be located outside the hazardous area if it is arranged to be operated from outside the hazardous area. In this arrangement, a Class 1 Division 1 rated switch is installed near the motor within the hazardous area. This switch controls a 120 volts control circuit that energizes or de-energizes the coil of a contactor located in a control panel outside the hazardous area. When the switch is turned off, the contactor opens, disconnecting power to the motor. This setup effectively provides a disconnecting means that can be operated from within the Class 1 Division 1 area without requiring a high-current, explosion-proof disconnect switch. The contactor itself must be appropriately rated for the motor's full load current and must be installed in an enclosure suitable for its location. It's crucial to ensure that the control circuit wiring and components are also suitable for the environment in which they are installed. For example, if any portion of the control circuit extends into the Class 1 Division 1 area, it must be either intrinsically safe or installed in explosion-proof conduit and fittings. In addition to the disconnecting means, overcurrent protection is another critical aspect of motor installations. Section 430.110 of the NEC requires that motors be protected against overcurrent, which includes both overload and short-circuit conditions. Overload protection is designed to protect the motor and its associated wiring from excessive current draw caused by mechanical overload or other abnormal operating conditions. Short circuit protection is intended to protect against high fault currents resulting from a short circuit in the motor or its supply conductors. In the scenario described, the 50 amp fuses in the control panel provide overcurrent protection for the motor. It's essential to verify that the size of the fuses is appropriate for the motor's full load current and that they comply with the requirements of section 430.52 of the NEC. This section provides detailed guidance on the selection of overcurrent protection devices for motors, including the maximum allowable size of fuses or circuit breakers. When selecting overcurrent protection for motors in Class 1 Division 1 locations, it's important to consider the potential for nuisance tripping. Nuisance tripping occurs when the overcurrent protection device trips unnecessarily due to transient current surges or other temporary conditions. This can be a particular concern in hazardous locations, where frequent shutdowns can disrupt production and potentially create unsafe conditions. To minimize the risk of nuisance tripping, it may be necessary to use time delay fuses or adjustable trip circuit breakers that are specifically designed for motor protection. These devices allow for temporary current surges without tripping, while still providing adequate protection against sustained overcurrent conditions. In addition to the requirements for disconnecting means and overcurrent protection, there are several other code sections that are relevant to motor installations in Class 1 Division 1 locations. Section 501.15 addresses sealing requirements for conduit systems. Seals are required to prevent the passage of flammable gases, vapors, or liquids from one portion of the electrical system to another. This is particularly important at the boundaries of the Class 1 Division 1 area, where conduit enters or exits the hazardous location. Seals must be installed in accordance with the requirements of Section 501.15 and must be specifically approved for use in Class 1 Division 1 locations. Section 501.125 addresses wiring methods for Class 1 Division 1 locations. The NEC specifies that wiring in these areas must be installed in rigid metal conduit, intermediate metal conduit, or cable with a gas-tight continuous sheath. All conduits and fittings must be explosion-proof and specifically approved for use in Class 1 Division 1 locations. Flexible conduit is permitted for short runs where flexibility is necessary, but it must also be explosion-proof and approved for the application. Section 501.130 addresses equipment grounding requirements for Class 1 Division 1 locations. Proper grounding is essential for preventing electrical shock hazards and for ensuring the reliable operation of overcurrent protection devices. All metal enclosures, conduit, and equipment must be properly grounded in accordance with the requirements of Section 250 of the NEC. In addition to the NEC requirements, it's important to consult with local authorities and insurance providers to ensure that the motor installation complies with all applicable regulations and standards. Local jurisdictions may have additional requirements or interpretations of the NEC that must be followed. Insurance providers may also have specific requirements for electrical installations in hazardous locations. By carefully considering all of these factors and following the applicable code requirements, it's possible to safely and reliably install motors in Class 1 Division 1 locations. Using a Class 1 Division 1 rated switch to control a contactor located outside the hazardous area is a permitted alternative to installing a high-current, explosion-proof disconnect switch, provided that all applicable code requirements are met. Remember to consult with qualified electrical professionals to ensure that the installation is performed correctly and in accordance with all applicable regulations. Additionally, always verify that all equipment used in Class 1 Division 1 locations is specifically approved for use in such hazardous environments. This includes motors, switches, contactors, conduit, fittings, and any other electrical components. Proper selection and installation of equipment are crucial for preventing explosions and ensuring the safety of personnel and property. Before commencing any electrical work in a Class 1 Division 1 location, it's essential to obtain all necessary permits and approvals from local authorities. This may involve submitting detailed plans and specifications for the installation and undergoing inspections to ensure compliance with all applicable regulations. Failing to obtain the required permits and approvals can result in costly delays, fines, and potential legal liabilities. Furthermore, it's crucial to implement a comprehensive safety program for all electrical work in Class 1 Division 1 locations. This program should include training for all personnel involved in the installation, regular safety audits, and the use of appropriate personal protective equipment, or PPE. All personnel working in hazardous locations should be thoroughly familiar with the potential hazards and the procedures for preventing accidents. Regular safety meetings should be held to discuss safety issues and to reinforce safe work practices. In addition to the technical aspects of motor installations in Class 1 Division 1 locations, it's also important to consider the economic factors. Explosion-proof equipment is typically more expensive than standard electrical equipment, so it's essential to carefully evaluate the costs and benefits of different installation options. Using a Class 1 Division 1 rated switch to control a contactor located outside the hazardous area can often be a cost-effective alternative to installing a high-current, explosion-proof disconnect switch. However, it's important to consider the additional costs associated with the control circuit wiring, the contactor enclosure, and any other necessary components. A thorough cost-benefit analysis should be performed to determine the most economical and safe solution for each specific application. In summary, installing motors in Class 1 Division 1 locations requires careful attention to detail and a thorough understanding of the applicable code requirements. Proper selection and installation of equipment, adherence to safety protocols, and compliance with local regulations are all essential for ensuring the safety of personnel and property. Using a Class 1 Division 1 rated switch to control a contactor located outside the hazardous area is a permitted alternative to installing a high-current, explosion-proof disconnect switch, provided that all applicable code requirements are met. Remember to consult with qualified electrical professionals to ensure that the installation is performed correctly and in accordance with all applicable regulations. This comprehensive overview should provide a solid foundation for understanding the key considerations involved in motor installations in Class 1 Division 1 locations. By following the guidance provided and consulting with qualified professionals, it's possible to safely and reliably operate motors in these challenging environments. The arrangement satisfies the requirement of being able to disconnect the motor from outside the hazardous area.